We welcome you all for the day 5 of our FTP. And here with us, we have Mr. Bipin Manuel, lead Microsoft Azure, COE, TCS. Okay. He's going to have a discussion on the topic trends in sensor data analytics industry perspective. So we welcome you, Mr. Bipin Manuel. And yes, Sebin.
Yes.
Yeah, you can. Yeah.
As Victor sir has pointed out, we are into the last day of our faculty development program on sensor data analytics here at Indian Institute of Information Technology, Kottayam. And today we are having the topic on trends in sensor data analytics industry perspective by Mr. Bipin Manuel, who is the technical lead, Microsoft Azure Cloud Center of Excellence, Tata Consultancy Services. Let's have a brief intro about the resource person. So Mr. Bipin Manuel is a versatile professional with expertise in product development, consultancy, software programming, and data analytics. He's a technical speaker and a trainer in IoT and data science. He has plenty of experience in full stack product development, descriptive, predictive, and prescriptive data analytics. So with immense pleasure, I would like to invite Mr. Bipin Manuel to the FTP on sensor data analytics. Over to you, sir.
Thank you, Sabine. Thank you, Dr. Victor. It's my pleasure to join Triple IT Kottayam again for a campus collaboration, yes, academic collaboration. So this time, yes, we are discussing the trends in sensor data analytics, and I understand from the faculty that this is the last day of the FTP program, and when I went the topics, I saw that the participants already had a glimpse of what is sensor data analytics and how it is impacting the different sectors in the world, especially agriculture, weather forecasting, and so many others. So I think you're now very much familiar and maybe experts in sensor data analytics by this time. Maybe definitely I will be going through some topics that maybe our company already working with our customers across the globe. Not only TCS, these are the few use cases or case studies that we create for our customers, especially maybe other companies like Accenture, IBM, Microsoft. So we'll go through some of the trends. When as trends, I just want to connect the trends with the different types of stories that we want to create. So maybe if you have seen some of the details you have already went through in the last couple of days, you can stop me in between. And also if you have any doubts or questions with respect to sensor data analytics, yes, we can discuss that as well. Maybe I will share some of the details for your interest. Maybe let's see, and maybe we can spend some time for Q&A. That is the plan. Okay. So with that, good morning once again. Expecting a very good interactive session with everyone. You can drop your questions in the chat, and again I will appreciate if you can ask the questions verbally. That is also good. Okay, so can you see my screen? Hello, can you hear me?
I was waiting for audience, but it is fine. Yeah, it's screen is clear. And
okay, fine. So when we discuss about different topics like data analytics, data science, deep learning, machine learning, then definitely Internet of Things, IoT, big data analytics, cognitive computing, then AI, right? So the baseline, the major backbone of all these concepts is data. We all know it. So this screen actually depicts the amount of data that is being created in 60 seconds in the world. So I captured this before 1 year because it could be multiplied by 10 or 100, we don't know. So if you look at the left side, so in every minute there are 600 plus YouTube videos getting created. So if you look vertically in the opposite direction, you can see 100 plus new LinkedIn accounts has been created, right? And again, like that, you can see how much search queries, how many downloads, so how many iPhone applications, then Google app and applications getting downloaded from Play Store. It's immense. So all these attributes I mentioned, or the features or the details I mentioned, are data. So the YouTube video, the number of YouTube videos may be, that data may be of interest for Google, right? Then LinkedIn. So again, Microsoft, they are interested in the LinkedIn accounts, how many new accounts. So we have many jobs recruiter companies and organizations, so they can definitely get so many insight from this. So let's see how this kind of data is getting a lot of value in the world. So you can see chat. Okay, yes. So phones are really smart these days. We know that. And I have a question for you. Just when we just discussed about data. So we all use smartphones, right? Maybe some of us we won't like smartphone, but still we are aware of what smartphones are and what they're capable of. Let's take iPhone, Samsung, or what else? Oppo, Vivo. So can you guess what are the number of sensors, or how many sensors are in a typical smartphone? Can you guess? Can you put in the chat? My question is, if you have iPhone 11 or a Samsung Galaxy phone, right? So how many sensors do you have? What do you think? How many sensors a typical smartphone will have nowadays? Can someone guess? 10 nearly. Manmada Kumar B, yes. 10, yes. Any other guess? Few dozens. Okay, that is tough to calculate, but it's okay. 8. Yeah. Okay. Hilal said few dozens, then Gina 10, right? Yeah. 8. Any other numbers? So I think the highest is now from Hilal, maybe few dozens, 12 into 24, right? Any other guesses? So I'm just showing your phone. Okay, so this is one of the typical iPhone model. It should be iPhone 5 or 6. So if you look from left to right, so you can see the proximity sensor. So when your hand goes near the phone, the light changes. Then ambient light sensor, right? The ambient light, the screen changes according to the ambient lighting setup. Then accelerometer, right? The speed. Gyroscopic, it measures with respect to the earth gravity. Then magnetometer, we know it, getting directions. Then yes, ambient sound sensor, the sound, right? And the output sound gets varied. Barometer, you get pressure values. Then always yes, temperature, humidity, the weather conditions that you usually see, and definitely M7 motion core processor. So this is almost 5 plus 4, that is 9. But if you see the latest smartphone nowadays, it is 35 to 40 sensors you have in a typical iPhone or any other smartphones. Not only iPhone, if you compare with anything you have, right, it will have many other sensors. It will come in a range of 35 to 40 sensors nowadays. So can you guess some of the things missing here and that is available in the latest smartphone models? Maybe, what is it? Any guesses? I think you all know the answers, right? One of them is fingerprint sensors, then face detection. Yes, biometric. Somil Kumar Gupta said biometric. That is correct. Yes. GPS. That's absolutely right. GPS is there. Yes. Right. You can see the number of sensors that is that is being listed in the chat, right? It goes till, if you take one by one, even if you take the minute details, maybe some of the sensors we don't understand, right? So that's being just getting created to make your life easy. So yes, that's answer maybe 35 to 40 sensors. Okay. So let me ask you a question. So now we are having a FTP session, right? Where we have so many participants from different areas of India. So if you want to analyze how many people from Karnataka attended this session, or how many people or how many faculty from Kerala or Tamil Nadu or Bihar or Jharkhand attended this session, how will you do that? So maybe you have an Excel sheet or online Google sheet, right? You can fill it up. So you'll fill your name, you'll fill your expertise or your specialization. Maybe some of you are experts in physics, chemistry, then statistics, right? Then what you do? So you'll just fill where you're coming from. So I'm from Chennai, Tamil Nadu, right? Then some of them you fill one from Kerala, right? Then what else? So that's it. So you will have how many fields now? I said name, that is name, then the state that you're coming from, your specialization, or any other. So some 3 fields, right? So that means in data science language, you have 3 factors or 3 attributes you have, right? So with 3 attributes, maybe Dr. Victor can understand how many people from Chennai attended this session, right? So that is an information for this institution, right? And the faculty to plan the FTP coming in the coming years. For example, if you find the number of participants from Bihar is too high, right? Yes, again, we can concentrate on Bihar participants and evangelize the sessions in the coming years. We can do that. That is one of the insights. And if you find that in the participants from Karnataka is too less, right? We can give Dr. Vitter and his colleagues can reach out to their friends and market the event much more, right? There's a few insights you get. So with 3 or 4 fields in your Excel, you understand how much insights you can build. So how many? So in Excel, we have only 4 factors or 4 attributes or 4 features we are analyzing to understand or to analyze the session participation. So if you compare that 4 features or 4 factors with the smartphone, right? I mentioned we are capturing 30 to 40 sensor data from each of the smartphones. You can imagine the amount of insights or the amount of information you can capture from a single smartphone, right? So from 4 Excel fields, you can find this much amount of information. And if you populate data coming from these 40 different sensors to a meaningful platform, maybe Excel, maybe not, maybe a cloud or your laptop, maybe what else? IBM SPSS or R or Python, right? And you analyze what is capable of this data coming from the smartphones. So who are the stakeholders of the data? So let's take GPS location, right? So there's someone who uses that data understand that Bipin is traveling from this location to other at this point of time, right? So it can be used for multiple. It can be used for multiple purposes, right? And again, so nowadays we the smartphones can capture the heartbeat and the number of steps you take, and also in the number of steps you take in 1 minute, 1 hour, right? And again, how much you travel in a cycle, they can capture the cycling distance as well, right? So your heartbeat is too high or too low, right? It's an insight for a hospital chain, right? Am I right? And again, so by capturing the data from this kind of smartphones, right, you can actually find a lot of insights. So maybe I'm sure that some of you heard about recommendation engines, right? It's very simple, right? So if you search for a smartphone in your browser, or in your Facebook or your Instagram, or anywhere, right? Or even your Google or your Safari browser, you're just checking for Nokia 9.1 or 10.1. So you're not planning to buy it, but you just want to check how that phone is Nokia coming back with the early legacy, and what is the spec, you want to check it. But the next moment when you move to Amazon or Flipkart or any other e-commerce websites, right, you get a recommendation to buy Nokia 7.1. So what is it? So you are in the browser or the application, Amazon is capturing your surfing data, and they're giving a recommendation for you, right? So that means it makes easier for you to find the smartphone that you're looking for in e-commerce platform. That is one thing. So, and again, it will take you to the pages which is more apt to find a good smartphone, right? So this is how the different stakeholders or the different consumers data are capturing the data from your smartphones and these devices. So let's extrapolate the same story to industry, right? If you take industries like manufacturing, we have a concept called Industry 4.0 we discuss. Okay, so I'm just trying to touch another concept for smart store. Okay, to understand more, let me stop this and share a video that is, I think, I hope you can see the video as well as you can hear the sound. Can you confirm? Can you hear? Someone say yes or no?
No. Yes.
Wonderful.
Yes.
Okay.
Yes.
Yeah. So this is video actually showcases the smart store concept, okay, by Amazon. Some of you are already familiar, and even in Kerala we have this kind of concepts already implemented. Okay, just see how it is happening.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout.
So have you seen this video or familiar with this concept? Anyone? Okay, so you want to talk about it, or have you tried some similar solution in your lab or with your students, something like that? Yeah, I will share the link. Yes, yes. Um, so how this is happening, right? You have seen that someone is walking into a store. Someone is walking into a store and they're picking few items. And again, it's not the usual trolley that we use in a supermarket, right? So they are using a smart trolley. So when you drop something into the trolley, it is getting detected the number of packets, the cost of that packet, and again, so there is a device which can capture all this information, sending that to the supermarket software we can call, or the enterprise software they're using it, and it goes to the checkout page automatically, right? It is getting updated. You are not waiting in the queue, and for the mobile app, if your credit card or if your any other bonus card are already attached, right, and the amount is getting deducted. It's very easy, right? You're not waiting in the queue. It happens in some 5 or 10 minutes, and a lot of time is being removed with respect to waiting in the queue, then understanding the price of the product. And also you have seen one other thing, right? So when you drop one item and when you remove it back, it is getting automatically updated on your mobile app, right? So how is it happening? So these are all enabled by sensors. Okay, so I'm not going into much detail, but let's understand. So we are getting into the store, how they understand it. Any guesses? So you're actually crossing a gate inside the store. So usually we can keep some IR sensors, right? Which can be detect the movement by infrared rays. You can do that, IR rays. So you can use IR sensors. That is one thing. So we use IR antennas to understand the the passing or the movement of objects. In this case, it's humans. Then, so how you are actually, so you can see racks. These are not racks. These are basically smart racks. So have you heard of lot sensors? Or to be specific, resistance strain sensors? I understand you all know these concepts and sensors because you are experts in this area. But this is how we use in some of the smart store concepts. Okay, so lot sensors. So just keep a lot sensor in the bottom of the rack. Just drop one packet of biscuit in one of them, right? Again, stack it with one more packet. Again, the third one. So what happens? If you pick the third one, the lot changes, right? The sensor value changes and is getting communicated to our the enterprise software device, right? So we understand the change in the weight and again the change in number of packets, right? And so let's come to the trolley part. So how they are understanding a packet fell inside the trolley and you're picking out or picking into the trolley, right? So here we are using RFID readers, radio frequency, right? So you can keep RF antennas on both ends of the trolley. That is one way of doing it. And that antenna sends a message that yes, that packet crossed the entrance of the trolley. And also you are keeping an RFID reader beneath the trolley, right? You can keep it so that reader can capture the values read by antenna, and reader can send the data to again this enterprise software via Wi-Fi or Bluetooth or 3G or 4G, right? So that that mobile app, it is getting updated that the number of biscuit packets or number of cereal packets is 2 and the amount of the packet is $50 or 150 INR, right? So anything of that sort is getting updated, right? So that we suppose that the cards are already attached and you can easily check out of the store. Then this is how we do that. So with this we have implemented a mini smart store across the globe, including India. We have one implementation for a retail customer in Delhi. We have done it. And we also have so many labs across different locations in India and as well as Europe and US geographies to showcase this concept. So we have this is Smart Store. Okay, this is coming very huge and in big volumes. We'll see in coming days very soon in our nearby locations. And so maybe if you think about the next steps of doing this, right? What are the possible advancements? So maybe you have already heard of image analytics or video analytics. So video analytics. So let's try to create a more immersive user experience inside the store. So we are placing a camera which can capture the images specifically in the face of the customer. Okay, maybe some people may go for shopping to relieve out of the stress. Maybe if they're more happy, they go for some shopping. If they're more sad due to some occasions, they will go for shopping, right? So the camera can actually capture all these details and then pick the mood of the customer, that they can do that. So for suppose one of the customers, they are really sad, or he or she is really sad, one of the personals can go to them and ask, ma'am or sir, can I help you, right? Maybe that single question can elevate the customer's experience inside the store. So this is one way of doing or implementing in Smart Store. Okay, let's move to the next concept. So let me ask you, so we can see some of the terms here: big data, analytics, and decisions. So we are trying to discuss the concept big data analytics, right? So I just want to, people sometimes mention as analytics, big data analytics, AI, so we may get confused. So let me make a statement that we are trying to analyze data coming from sensors or any such devices. Okay, so the example that we discussed in the beginning of the discussion. Okay, so you want to capture some insights based on the participation in this FTP, right? Based on your university name, your college name, or your state, or your place name, or your name, and we want to. So how we are doing it? So we are doing that on an Excel. So my question is, what would be the basic or major differences between analytics and big data analytics? So when we do an analysis on the Excel, what will you call it? Is it a big data analytics or data analytics? How will you call it? Any guesses? Anyone? Waiting for an answer. Okay. So not only chat, if you want to unmute and speak, that is also fine for me. Anyone? Data analytics. Dinesh. Okay, that's right. Yes. So when you have the names of the faculty who are attending the session on Excel, is their college name, university name, and the state name, and find out how many participants are there from Kerala, Tamil Nadu, Bihar, or Jharkhand, right? It's easy to understand, right? So let's go to big data then. So how will you analyze the data in platforms like Facebook, Twitter, then LinkedIn, right? How will you do that? How will you do that? For example, let's imagine that. So we all talk about environmental sustainability, then preserve nature for future, right? Protect our mother earth. So there are a lot of summits happening around the world, a lot of programs, campaigns happening around the world, right? For example, there are videos people are putting in the Facebook saying that preserve future, save trees, that is coming from Sweden or Australia or India. So as a data analyst, you just want to understand what is the response from different Facebook users to this kind of videos? Do you understand? So what is the first step? So if I am a data analyst or a big data analyst, I will open my Facebook, right? Maybe I will search for people like Greta from Sweden. Then I will look for some videos from UN, United Nations, and go through that videos. And also when I go through that videos, I will check for the comments. I will check for the number of shares. So how will you do that? And understand what is the kind of responses they are getting to these videos, or what is the emotion, right, these videos are conveying, and what is the quality of these videos that is getting shared. So when you analyze this situation, you have to analyze the comments, which is basically text in our language. So you have to analyze the videos, right? We have to analyze the videos by frames. You have to do that. Then you have to analyze the different share patterns. That maybe Bivin shared that from India and Joseph shared that from Australia, right? Okay, or someone shared from US. So how will you do that? Then what else? So there are positive and negative comments. Some of them will go for preserving the nature. Some of them will be against that, right? Someone may think industries are growing and we may need more development, right? So we all know other treaties like Paris treaties and everything. So there are different kind of negative and positive. So how will you analyze? So Facebook is a global platform which spans across the globe, which spans across different type of people and cultures. So how will you do that? So is it possible to do that with Excel? Yes or no? I can see an answer like answer from Dr. Shankar. Yes, use API, and that is right. Yes, we can data from social medias. Yes. So if you pay Facebook or Google for some APIs to capture this, yes, we can use that APIs and do this easily. Yes, I agree. So how will you do this scenario? How will you analyze this data? Can you use Excel? Did you get my question? If my question is not clear, I can repeat. Can you do this with the Excel? Any guesses? No, Ashik says no. Yes, that's the answer, because we know when we analyze this kind of a situation, we are going to analyze 500 million, maybe millions of users, right? People like everyone is using Facebook, maybe we don't know. So that's where we need some big data platforms to do this, right? So we talk about sensors, right? So now we are talking about Facebook. So even for a sensor data analyst or sensor data scientist, so the Facebook data is we also consider as a sensor data or even API data, right? API, the people maybe who are hearing this for the first time, application programming interface. So why we are using APIs? Let's touch that point for a few seconds. So you know that giants like Facebook, Google, Microsoft, they're capturing data from different sources in the world, like especially social media. And maybe governments or organizations want to check that data and then analyze and build some insights, how they can do that. Because they won't simply give it, right? We have to pay some money to Google or Facebook and get some APIs, application programming interfaces. So they will provide these APIs and we can access these APIs through some protocols like HTTP or HTTPS. So the basically the TCP IP protocols. So we can consume that APIs and we can write our own logic in Java, C++, Python, Spark, right? Or any other languages, and we can analyze and use that data for good costs. So coming back to this, so to analyze this kind of Facebook in campaign, right? Like we were discussing, how the environment, how the videos which promotes environmental sustainability are creating different types of emotions and response in the world. So if I want to analyze this situation, I want to consume some APIs, or I can, also I can collect the all data required myself or through my organization and analyze what is the emotions, right? So that's where we need some big data analytics platforms where we can use Python, we can use Spark. So there is something called Spark Stream is very good to analyze big data, right? Then you have IBM tools, you have tools from Microsoft, you have tools from TCS. So you can do that and build insights. So which is not that easy with the Excel. Okay. So now we are moving to the concept called Industry 4.0. Okay, so before we touch the concept Industry 4.0, you can see Industry 1.0, which started years back. So the entire industrial revolution started with the steam and water, right? Then Industry 2.0, you always remember the time where GE and Ford mass produced a lot of vehicles in the world, as US as a center, right? Then Industry 3.0, which is the 1980s and 90s, where the first time the people send emails, right? Then using mobile phones, electronic and IT systems, and finally we are entering a 5.0, but now we can say we are in a era of Industry 4.0. We have cyber physical systems. That means all the systems in the world, or the manufacturing floor, or logistics, or travel, hospitality, pharma, hospital, everything, right? They're interconnected. That's why. So when you have all devices, all machineries, people are interconnected via network. Not be 3G or 4G RAN or Wi-Fi, Bluetooth. You can have LoRa, you can have WiMAX, anything. And if you can interconnect all these devices or all these objects, and you can build insights, you can call it as Industry 4.0 case or Industry 4.0 use case. Okay, you can call that. So maybe we are using this concept Industry 4.0 to build solutions for our customers. So how we can implement our Industry 4.0 solution? So it's the primary prerequisite would be to connect the devices in their factories and their different business units. That's how we do it. Then, as part of Industry 4.0, this is a concept which gains a lot of prominence nowadays. Okay. Can you guess? Maybe you can see two people standing. They are looking at an iPad. Then you can see a projection on, right? A projection on the floor. You can also see some charts, parameters. Someone guess about this concept? Any guesses? What could be? So this concept is introduced recently by our major organizations, right? So can you guess what kind of concept would be this? Augmented reality, yes. Dr. Shankar says augmented reality, yes. Digital twin, Ashik said digital twin, that's correct. I think both answers are correct, but yes, it's a concept of digital twin supported by augmented reality. Okay, yeah. So yeah, then how we are doing it? So what is the importance of digital twin? So digital twin are basically a digital replica of real world objects. If you want to replicate your mobile phone as a replica, digital replica, you can do that. If you want to replicate your car engine as a digital replica, you can do that. If you want to replicate your air conditioner, you can do that. If you want to create a digital replica of your refrigerator, you can do that. And why we are doing it? So what you're seeing on the screen right now is a aircraft engine from Rolls-Royce or Boeing. It could be from any manufacturing, right? So if you look at that, you can see a number of cylinders. So typically a car will have one engine, right? So like that, aircraft will have minimum 3 engines or 4 engines. It will go till 5, 6 or 8. So suppose a flight traveling from Kochi to Dubai, okay, a Boeing plane. So maybe in the flight assistants or operators find that there are some disparities in the data coming in the cockpit, okay. So they want to analyze the sensor data which is coming. So they found that the steam pressure or the in pressure which is residing in the which comes from the engine cabins are a bit low compared to the threshold values, and the flight cannot be taken without checking. How they are going to do that? So they should be going to the engine cabin and check the engines, right? That's the way to do it. So when they do it, how much time, how much manpower, how much supporting equipments are required. So let's imagine, before having a human intervention or machine intervention to solve the situation, if it is a minor problem, if you can remotely manage this. So when I tried travels from Kochi to Dubai, and someone who sits at US, who is who are the creators of this engine, for example, Rolls-Royce or Boeing, right? So you can send an alarm to that the OEM manufacturer and tell them, so we are facing a minor issue, can you check the issue so that we can take a decision to fly in or not? Okay, so how they can do it? So they actually open the digital twin application. How they're doing it? They are opening their iPad. They are wearing a augmented reality headset. So there are HTC Vive headset. There is HP Oculus. So there are different headsets which can do it. And then they're using that augmented reality or virtual reality or mixed reality headset and looking through the engine parts, right? So instead of opening it manually, by sitting in US from a command center, they're looking at the engine parts, right? And understand what happened to the engine without opening the engine cabin, without disturbing the passengers or without disturbing the crew, anything, right? They're just doing that use in few minutes through the digital twin concept. You can use the same concept, okay? You can use the same digital twin concept. For example, in the rigs, the oil rigs, the rigs, right? The structures, the huge structures which you can find in the oceans or sea to mine oil, right? So when something happens, in the drilling process, and the drilling machine is not working, how we are going to check it? And the human, maybe one of the engineers will go inside and check it. It's a very dangerous situation, and you can see many accidents have happened in the past. So that's where again you can create a digital twin of the rig setup of the drilling areas, and you can remotely troubleshoot what is happening, which can stop the drilling process. You can do that. So that's a power of digital twin. Okay. So this is again a few actually on the definitions, and again how we are doing it. So how this is possible? So all these end devices are connected through network, and we are capturing all these sensor values emitted, and we are storing that locally, or we can store that in the cloud and analyze or monitor or remotely predict what is happening to the physical asset by looking at digital twin. Okay. So again, with that, so this is we already discussed. One of our participants already mentioned the augmented reality, right? So when we discuss augmented reality, we should also discuss virtual reality, right? Two similar concepts, but anyone guess the differences? I think we are using this. Okay, can you see the screen? Can someone guess the differences between augmented and virtual reality? Any answers?
See, the participants can unmute themselves and interact with the resource person if needed. Okay.
Yeah, I mean, maybe I can stop here for a couple of questions right now if you want to discuss. That can be also done. Okay. Okay. So augmented reality is actually when you augment a situation and scenario on top of a physical object. So what you see here in the right on the picture, you have a mobile phone and you have inbuilt augmented reality application in your mobile phone. How you are building it? You can use something, different softwares for that. You can use Unity for that. You can use Maya for that. to build AR applications. Okay, so for example, if you are actually walking through the streets of Kochi, and but you want to see the streets in US, how we can do that? So you can create an AR application, and when you have some landmarks in Kochi, you can open your mobile app, right, in the AR application, and keep that on top of a marker and see how the people are walking through the streets of US at the same time you're walking this Kochi. You can do that. And virtual reality. So how you can do that? So virtual reality is like you're traveling into a different situation or different world through the headsets you have. So you can see a virtual headset in the picture, right? It's more like Google Cardboard that you see in the picture, right? I think this is one of the cheapest headsets that is available in the market. So HP is providing a very good headsets, right? HP Oculus. So I think we are using this concept when we play games, or when you attend an exhibition, right? Maybe something like a science exhibition, or when you actually watch some 4D or 5D videos, you can experience this. So the basic difference is AR, you're augmenting on top of a physical object, and VR, with the help of a headset or any other application, you are entering in a different world. That's the basic difference. Okay. Yeah. So apart from AR and VR, we also have something called MR, mixed reality. That is also one. Yeah, we can see some answers in the chat, but yeah, yes, we are discussed. Then automation, yes, automation. Everyone wants automation, and automation is really important. That's what we say, right? So why automations are important? Okay, so how we can increase the time for producing a machine or a car, right? We can reduce a lot of human efforts. We can actually avoid human casualties. It can be done a lot of advantages, right? Again, it will have another very rational, like it is reducing the number of labors to do that task. Yes, I agree. Yes, that is there as well. Yes. So there are two sides of the coin, right? So this robotics, this automation is enabled through artificial intelligence, right? Then it is also enabled the robotic arms that you see here, right? So it can actually do assembling the car engine or car parts. It can perform robotic surgeries. In Kerala, so we are doing it. Then it can perform different troubleshooting mechanisms where we can deploy. You can actually deploy robots to extinguish fire in such a dangerous situation. You can send robots in a drilling area. You can send robots in the mining area, right? Coal or oil. So a lot of, and again, you can, so drones are another way of doing it, right? You can actually use drones for agriculture. You can use drones for surveillance, especially in a scenario of earthquake or flood. So it's all applications of robotics and automation, right? So these are few trends. I think with that, we are just trying to see the mother of all such trends, right? How the different things are connected, which is IoT, Internet of Things. So we have discussed smart stores, we have discussed the smart engine monitoring, we have discussed digital twin, then we discussed industry 4.0. So these are few major concepts that we see in industries and academia, and where they are actually converging in a single point. If they're converging in a single point, that is Internet of Things, right? So if you look at so IoT in agriculture, I think you have already had a topic of sensor data analytics in agriculture. So I'm just curious to know what would you have discussed in the topic. Can someone share, anyone, so that we can touch that area? I mean, I can share what we are doing in that area. Okay, someone is there to explain what you have discussed in that session? Dr. Shankar says mechanization is automation. That's right. Yes, yes. So when we say mechanization, yes, we're capturing data from all these mechanical devices over a network, and we take that to a cloud platform or a private platform, because if the maybe in the medical customers or pharma customers have concerns or the security of the data, we can keep the data in your own factory, yes, and we can automate whatever required with the help of the data coming from. Yes, Dr. Shankar, you're right. Yes. Yeah, so my question was, can you give some insights on what you have discussed in your previous session on sensor data analytics with respect to agriculture? Can someone volunteer quickly? Hello? Hello? Yeah, can someone in the share in the chat maybe some concepts? Yeah. Kavita Goyal said yes, 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 Kavita. What do you want to share?
Maybe you can repeat the thing so that they can.
Okay, okay. I think your voice was low. I was.
No. Now it will be right.
Yeah, now
Yeah.
it is good. Yes,
Yeah.
yes.
Please repeat that question. Maybe they might have missed. They can come back.
Okay, so my question was, you have already discussed the topic, the sensor data analytics in agriculture, right? Just curious to know what you have discussed in that topic in the previous sessions. Is my understanding correct? Is that done?
Yeah. It's done.
Yeah.
Different
Okay.
applicative perspective. There's
Faisal Lab. So what is it?
No,
Faisal Lab.
no, it's like agriculture based. It's a company. They're talking. It's an app. They have a talk. They were discussing. Like it's an organization. Puzzle is a company. Yeah.
Okay.
Yeah. It's like a agriculture centric. Yeah. That's what they are talking. Yeah.
Yeah, again, Dr. Shankar says we use sensors like humidity, temperature, soil moisture. Yes, yeah, I think that's a good input. Yes, that's right. So there are many startups organization coming up nowadays, like especially we call it as social startups or agriculture startups, which they are trying to help the farmers across the country and the world by building innovative and next generation solutions. So in TCS, we have built similar solutions like so the same solution that Dr. Shankar just mentioned, right? So we can actually deploy temperature and humidity sensors. So now we know that nowadays when you have some crops in the field, we are planning to water it in the morning, maybe in the evening, right? Twice a day. We don't know whether it is required or not based on the climatic conditions or the nature of the soil. Whether it is required or not, we are doing it. So let's imagine an area which is very scarce with the water availability. How will you do that? So that's where we can deploy some humidity or temperature moisture sensors, right? So that understand the water content in the soil, and you can actually create some alerts. And the moisture content is going below a threshold. Yes, you can send a message to the farmer or any operators to recommend for a watering practice. If the moisture is above threshold level, maybe the farmer can avoid doing watering that particular evening or that particular day, so that he can save time as well as he can save a lot of water. So that's how we are making things in agriculture very smart. So mentioning agriculture as well as we also know in countries like Japan, New Zealand, cattle farming is one of the emerging areas, right? So we also have in India, but still compared to that, the cattle farming and the milk products are major resources of income for countries like New Zealand, for example. So we have deployed IoT solutions in these countries which can capture in the availability. So you know, right, this when these cows go for gazing across a huge land, if one or two people are only managed, they don't know where are they have to go here and there to understand the location of the cows. So we actually tag GPS magnets to these cows so they can locate that. And again, how they can actually understand the health of the cows, right? Because if you have 1,000 or 2,000 of cows, you can't go and manually check their health, right? So what we use is we use pedometers, the device which can give the number of steps that you take, right? So based on the pedometer analysis, we can determine this is how this cow is behaving, right? And they are absolutely with good health. So we can take that kind of insights. So that's how IoT is helping in the areas of agriculture and cattle farming. And I think we already discussed other parts, right? So going to that, I mean, how IoT is working, right? That is one area we need to understand. So let's see from bottom to top. So Internet of Things, in the different application layers of Internet of Things. So you have sensors in the bottom. You have smartphones, you have temperature sensors, you have humidity sensors, you have air conditioners, you have lights, you have Alexas, you have Siri, you have everything in the bottom, right? So sometimes the temperature sensors are not capable of sending data to internet, right? So if you take a simple temperature sensor, can they send data to cloud? No, they can't. They can just send the data to the nearby mobile phone or device, Arduino or Raspberry Pi. That's only possible. So that's where we use something called gateways, IoT gateways, which could be necessarily a Raspberry Pi or Arduino board, right, which is having some internet capabilities, which 3G, 4G, Wi-Fi, LoRa, WiMAX, and send data to cloud. So once data reaches the cloud, right, you have an infrastructure platform which can host this data. So you need an infrastructure for processing the data, ingesting the data. If the data is not correct, right, maybe you want to clean it, right? You have to cleanse the data, right? Then so you're using data to predict how much steps the cows has taken for today, but you have to store it for the future predictions. So you need storage in the data, right? So you also have some application services to all this. What are these application services? So application services are necessarily industry 4.0 cases, AR solutions, VR solutions, digital twin solutions, data analytics, AI, robotics. So these are the different application services you will build on top of sensor data which is residing in the platform by processing it, right? And finally, if you see the response layer, the upper layer. So this structure remains same for finance. Not sure you're able to see it. Okay. Yeah, you can actually apply the same data and concept for finance, government sectors, healthcare, agriculture, energy, water, factories, and transportation. You can do that. So these are the basic layers of IoT, right? Where we capture data from sensors, extract to devices like Raspberry Pi, Arduinos, or gateways, send that to cloud. Also, you can have an option not to send that to cloud. You can process in your factory itself, in your college itself. You can do that. And in the platform, the cloud, you will have different application services for robotics, visualization, mobile apps. You will have everything, and you can create domain specific, that means government specific or health specific and agriculture specific services to building sites, right? So that's what we are doing in nutshell in Internet of Things: sense, extract, analyze, and respond to a situation to building insights, right? That's what we are doing. Any questions? I think we are almost reaching the end of the session, right? So maybe we'll take up some questions and close it.
Bipin, hello, Bipin, I'm Shankar.
Hello.
Hello.
Hi, Dr. Shankar. Yeah.
Bipin, can you hear me?
Yes, yes, a little more louder will be helping,
No,
Dr. Shankar.
because here the connection is having some problem. That's why I was unable to talk. Otherwise, I would have talked with you.
Okay, that is
Uh,
okay. That is okay. Go on.
just one question is how we'll use this authentication of all these devices, because the number of devices in the network is so high, isn't it? So how do
Yeah,
we authenticate all these devices, whether it's a genuine one or whether it's a fake one? How do we know that?
exactly. That's a really valid and awesome question, Dr. Shankar, because when we talk about data, IoT, or any such sensor data, right, the security is a bigger concern. We are also facing challenges, I mean, to accommodate that request in our implementations. So the basic flow that we are actually doing in this kind of a concept is like we are connecting devices and we are extracting data from it, right? So when you build an enterprise platform to create a sensor data solution, you can imagine that anyone can attack that platform because all devices are connected, right? So we should protect that from any attacks. So how we usually authenticate the devices is there are different ways of doing it. So one is through certificates. So specifically S.509 certificates, it's built on SHA-based, SHA-based algorithm. So what we do is like when you register a device, for example, if you have a device in your factory, when you register a device, we'll provide a certificate from TCS for that particular device. And when the device actually connects with the platform for the first time, right? When I say platform, it's application, the mobile application or the cloud application you have for the first time. The platform will authenticate that device with a certificate because it will be verifying that certificate, right? It can be done based on user password name mechanism. We can do that again, as I mentioned, certificate based. We can do that, and again, so that's why we do, Dr. Shankar, in majority of the cases. And again, it will change with respect to the nature of devices. For example, if you are connecting air conditioner, so there we actually use a protocol called Modbus, right? And Modbus actually provides a Modbus protocol authentication specifically for refrigerators. That means if you want to capture data from air conditioners, not refrigerators, if you want to capture data from air conditioners, I mean, if you want to capture that sensor data to understand the health, the monitoring, or the operation of these air conditioners, we can have Modbus authentication. We do that. And if you're connecting a car, right, we use CAN bus protocol. So the authentication mechanisms will change with respect to different devices. But overall, to conclude, we use certificate based authentications, Dr. Shankar.
Okay, thank you.
Yeah. Apart from that, to protect your devices, right? So you can see something called gateway here. So you have a Raspberry Pi, you can have you can have Arduino boards. You have gate for some Intel, Hitachi, Siemens, TCS. So there is a way of doing it, protecting that as well. Like you can use a hardware security module, HSM, right? So we can have, using HSM, we will build some TPM, trusted platform modules. That means if someone snatches your gateway device, your sensor device, right? So then also it will be protected. Someone who can actually decrypt that TPM module can only open that device. So that kind of mechanisms are to protect devices also. If someone picks it from the site, that can be also done. Yeah. So it's here in, okay, I didn't say that. It's in Telangana, there is Tipsandra cattle farming. Awesome. That's great. Great to know, Dr. Shankar. Thanks for sharing. Thank you. Any other questions? Anyone? If you have any question, you can drop in chat. Okay. So actually, how you can build the skills are required to do this. Okay. For especially, I mean, maybe you have heard of these skill sets in different scenario or different platforms, or you're teaching the students in your curriculum, right? So in IoT, yes, to work with the devices, C++ and Python are really good. And again, working with cloud, especially with cloud like Microsoft Azure, AWS, IBM Bluemix, you can actually practice skills like Spark, Scala, then big data, Hadoop and Java, you can do that. And analytics, how you can analyze data, right, which reside in the cloud, which comes from the sensors. So you can use R. I am sure you will be using it. You can use Python, then Spark. Apache Spark is very good for big data. Then there are a few things I haven't mentioned here, like Google TensorFlow. You can use it, right? You can use Google TensorFlow. That is also good. So when you build insights, it is very important to do that. You can create some useful user interfaces to show what you have found, right? One is HTML5, the web dashboards that you see, the responsive dashboards that you see. We can build dashboards on top of Angular. You can create on top of React. You can create on top of Sidecore. You can use different mechanisms. And finally, mobile, Android, iOS, you know it. So these skill sets are very good to create sensor data solutions. When you say sensor data solutions, they're basically IoT solutions. And also, if you want to specialize in any of these layers specifically, you can do that. Okay. And if you build your skill set, what are the different roles available in the industry or in a company like TCS? So this is it. Edge developer. When you work with IoT devices, we call them as edge developer. Then when you work with cloud, right, because cloud is really important, and we are using cloud infrastructure to analyze data and create insights. So cloud engineer. Then big data developer who work on data, right? Then data analyst, right, who analyze this data resides in the cloud or your factory systems. The network, right? So security is a bigger concern. So you have to create segregation layers between the networks, right, to protect data and protect the systems. So cloud architect, user interface developer, someone who creates the web interfaces, beautiful interfaces. Then mobile app, right? So instead of web apps, websites, you can create mobile apps. You can do that. And when you gain some experience like 8 years or 10 years, you can become a cloud architect if you are a cloud engineer. And when you have 8 or 10 years of data analysis, maybe more than that, 10, 15 years experience, right? When you are an expert in domain like health or agriculture, and you are a very good programmer with knowledge in business domains, you can be called as a data scientist. Okay. So there are different other roles again, like product owner, product manager, right? Then big data architect. So when you become experienced big data developer with a number of years of experience, yes, you become big data architect. Then one who specializes in Microsoft Azure, they become Azure architect. One who specializes in AWS, they become an AWS architect. And one who manages the different infrastructure and deploying components, they becomes an Azure DevOps consultant, right? You heard of DevOps. Then so CI/CD is there. Then to enable the security, you have a security architect. You have to set up the infrastructure required to host the sensor data solution. You have infrastructure architect or infrastructure engineer. So to create firewalls, network security groups, you have a network engineers and network architects. So there are different roles available in industry to do that. Okay. Any questions? I think we almost reached the end of sessions. We'll take a few more questions and we can close this. Okay. And we can, and based on the sessions that happened the previous days, right? If you have any questions, you can share to me. I will try to answer that as well.
Participants, either you can type the queries on the chat, otherwise you can unmute yourself and you can go ahead with your queries. I hope Bibin Manuel can answer you for the queries related to data analytics in better way. Yeah. Okay, fine.
So participants, just take it as an opportunity to interact with the resource person. Normally in sessions, we don't get more time for the question answer session. So they will be rushing towards the end and we will have to break the session. They will be engaged with any other sessions right away. So take it as an opportunity to interact with the resource person and to clear your doubts with him. Yeah.
Bipin, can you mention some of the protocols that is being used currently in TCS? Hello.
Yeah, sure. So in TCS, actually, we are working with, I mean, majority of the devices that we see in the industry. Okay, like we work with devices, as I mentioned. We work with refrigerators to capture data. We work with different manufacturing industries. If you take cement manufacturing, if you take engine manufacturing, or again aircraft engines, we all do that. So to connect the sensors, the basic type of sensors, as you know, we use protocols, right? I mean, TCP/IP protocols where we connect with devices, HTTP over HTTP or HTTPS. And if you think about other machines like turbines, if you take some turbines, right? Steam turbines or water turbines, we will connect with devices which support protocols, Siemens S7 protocols, Siemens S7.
TCP/IP is unsuitable, isn't it?
What was it?
TCP/IP is unsuitable for this kind of applications, especially IoT.
What kind of application? Again, it depends on the application, right? I mean, for example, when you capture sensor data, for example, if you're capturing data from an ERP system or a management system, right? And the only way to capture it through will be a TCP/IP protocol. But if you want to capture data from a turbine system, it is a Siemens S7 protocol, right? We can't use HTTP. Yes, we can't trust. And again, TCP/IP, we can't say we can't trust it, Dr. Shankar, because it was early HTTP. It is now HTTP. Yes, that means it is actually enabled by SSL, socket layer security, on top of TLS. So again, that is the SSL enabled with TLS, that is called transport layer security, right? So that means when you use HTTPS, which is part of this protocol, for transmission, it is enabled with TLS 1.3 decryption and security mechanism. So TLS is basically transport layer security. So we can trust that right now. If it is HTTPS, we can trust that transmission right now. But other than that, other protocols we use is CAN bus, Modbus. So it depends on devices, it will change. Then also coming to in the industry 4.0 scenario, we are using protocols like OPC UA, DA, right? And again, if you want to connect the legacy systems, the old PLC systems of historians, we use OSI Pi, we do that. The SCADA systems, yes, we use OSI Pi again. So these are the few protocols that we normally use, Dr. Shankar.
Okay, thank you.
Yeah.
Bipin, I think we have a query in our chat box. Like,
Sure, yeah.
yeah.
Sneha Deshmukh is asking, what is the procedure of doing real-time data analytics for data generated from agriculture field, example moisture sensor? So I will provide the steps. First, you can have a moisture sensor. You can buy it online or from the electronic shops. Okay. So you can have a moisture sensor. You can connect that to a Arduino board, which is again available online. Which comes around some 500 to 600 rupees. You can connect that moisture sensor. If it is Wi-Fi enabled, you can connect with Wi-Fi, or you can couple it directly. Okay. Then you can actually write a mobile application which can capture data from this Arduino board, which says which will normally, if you can, how will you see that the change in the moisture, right? So and the change in the moisture sensor is like you can pour some water and you can see how it is changing, right? So when you pour some water, the moisture level changes. It will come down or come low, right? So you can see that means you are augmenting that situation with the help of a moisture sensor in your hand. And if you think that the behavior is going correct, you can deploy that moisture sensor in your small pot at your home or your college and see how it is behaving with respect to different climatic conditions. And also, if you don't have a luxury of building a mobile app or web application, right? You can have some LED displays or something like that, okay, to capture, or any other displays to capture the change in the variation of moisture values. You can do that. And again, if you want a full-fledged sensor data application, you have to create some components to capture the data. which you can write some program in C++ or Java, right? And again, if you want to change the representation of data in some way, you can actually have some data processing logic. We call it business logic. And if you want to check the data after 6 months or 5 months, right? You can do that with the help of with the help, yeah. So with the help of any other logic, yeah. I mean, with the help of a database. If you want to if you want to store the data for a SQL, if you want to store the data for a later period of time, you can use SQL database. Then if you want to store it for, if you want to store it for later for any such NoSQL databases like Cassandra or MongoDB, you can use that as well. But all these databases will become more relevant when you have a large amount of data. That means you have a 10 or 50 or 100 types of moisture sensors in your scope. Okay, that's where actually we can use it. Is it clear, Sneha?
Yes, there is one more question in the chat box regarding the NPK sensor.
Okay, I think again this NPK also is related to the agriculture, right? You want to check the soil, soil components. I think again, I'm not sure about the cost of NPK sensor, but in the objective of NPK sensor is also to understand the different the composition, and again the different attribute levels in a soil, right, with respect to agriculture. But if you just compare the cost for NPK and moisture, but if you can actually um, achieve the same functionality with a moisture or humidity sensor without NPK, if you want to just explore. But if you have a case in your mind, like I mean, if you want to explore that for a PhD or any such science solution, you can specifically go for NPK sensor. It's really good. But I mean, just to before you go for a full-fledged implementation, I will recommend to use a moisture sensor, Takasin, to do that. So just verify your solution with a moisture and humidity sensor first, along with the same combination I just mentioned to Sneha. Then you can go for NPK sensor. Yeah, that is good to go. Yeah. I think if there are no other questions, maybe we can conclude. Thank you once again.
I hope no more doubts from the participant side. So thank you very much, Mr. Bipin Manuel, for spending your valuable time and experience and knowledge with us and our participants. And yes, thank you so much for your time. And yes, Sabir, you can.
Yes.
Okay,
So thank you, Bipin Manuel, for sharing your time, for delivering a wonderful session over here and proactively taking up all the questions from the participants. It was a wonderful session. So we are on behalf of IIIT Kottayam, we would like to thank you from bottom of our hearts, and we would like to see you again in any other FTPs which is being organized here at IIIT any day. Okay, so thank you very much for joining us.
Thank you for your kind words. Thank you. It was a good experience discussing with you all. Thank you and all the best.
So, dear participants, we are taking a break right now, and we will start our next session at 12 p.m. Victor sir, would you like to say something about the quiz and all?
Yeah, guys, participants, kindly make note of it. Like our quiz will be available as our third session, like from 2:30 onwards, which is planned to 4. Okay, so like our valedictory will be from 3:30 onwards, so we can have a small valedictory function. So with that we can wind up. So you can take up the test between 2:30 and 4, and we can extend up to 4:30 as well. Okay, so make sure of it, and you try to complete your quiz, that's the exam. Otherwise, it is a mandatory to complete. Without that, there won't be, sir, you are not eligible for certificate from the AIC. Kindly make note of it. Okay, that's fine. Mr.
Okay.
Yeah.
Yes. Thank you, Victor sir. So we will break and we will resume our session at 12 p.m. Thank you. Meanwhile, the attendance link is already available in the chat box. You may please fill your attendance form. Yeah, for the quiz, there will be around 25 questions. Yes. 25 questions will be there. Yeah.
See, there is no specific time, so you can attend any time between this. Between 2:30 and 4, you can attend any time. There is no restricted time for the exam. Yeah. And difficulty level is nothing, like whatever they discussed during our session, that will be there. Like the content discussed during our session, only the questions will be from that. As per the passing mark is not regulated by us, it is regulated by AICT. It is 60%. That means you have to get at least 15 marks. Kindly make note of it. You have to get 60% of marks and 80% of attendance. Then only you will meet the eligibility for getting the certificate by the AICT. And moreover, you have to fill the feedback form also. That will be provided by the AICT on their website. Yeah, I hope it is clear.
Yes.